Today we are going to solve question number 13 from Selina publication. So we will write over here exercise 2C and we are going to solve question number 13. Let us read the question. A car travels with a uniform velocity of 25 meters per second for 5 seconds. Then the brakes are applied and the car is uniformly retarded and it comes to rest, which means its velocity then becomes 0 meter per second in further 10 seconds. Find the distance which the car travels before the brakes are applied. Before the brakes are applied means in 5 seconds how much it has traveled. But now in these 5 seconds there is uniform velocity. So we will write uniform velocity is 25 meter per second and the time for that is 5 seconds. Okay, so I have considered this and I've considered this. Now if it's uniform velocity, then you will say that velocity is equal to distance upon time, and therefore our distance traveled in first 5 seconds will be equal to, distance will be velocity into time, which means we will take the velocity as 25 meter per second multiplied by time is 5 seconds. Now second and second gets cancelled and 25 into 5 is 125 meter, and that is our answer 1. Okay, so we found this part before the brakes were applied. Let us see what we are being asked for the second part. The retardation and the third one is the distance traveled by the car after applying the brake. Now the brakes were applied. When they were applied? They were applied for further 10 seconds. Can you see that? Further 10 seconds the brakes were applied. But we have to find the retardation. Now retardation means, remember, it is negative acceleration. So we are going to look at the formulas which have acceleration in them. Remember our equations of motion. The first one we have is V is equal to U plus AT. The second one is S is equal to UT plus half AT square. And the third one is V square minus U square is equal to 2AS. Now we have initial velocity, that is 25 meter per second. This was carried on for 5 seconds. Then we applied the brakes. For how long? So if this is our first part, in our second part we will say that initial velocity is going to be 25 meter per second. And the final velocity, that is V, small v, this is the final velocity. And obviously when we apply the brakes, can you see it comes to rest? Can you see this part over here? It comes to rest. So it becomes final velocity is 0 meter per second, and all this happens in the time interval. If we call this time as t1, then this becomes our time t2. This is for 10 seconds. So we have v, u, t, and we have to find acceleration how much. So v, u, t and a, that means this formula is applicable, yes? So let us write the formula. V is equal to U plus AT. Now we are going to consider this time, so I'll just write T2. What is our final velocity? 0. Can you see that here? Is equal to initial velocity is 25 plus A multiplied by T2. What is our T2? Just now we wrote over here. See here. What is it? It is 10 seconds. So we will have minus 25 is equal to 10A, and therefore A is equal to minus 25 upon 10, which is minus 2.5. So we are asked to find the retardation. So we will say therefore retardation, which is equal to minus acceleration, will be minus into bracket. The value of acceleration is this. So we will write minus 2.5, and that will be 2.5 meters per second square. And this is our answer 2. Okay. Now let us come to the third part. In our third part, let us look at our question. The distance traveled by the car after applying the brakes. So we have distance traveled after applying the brakes, and that is to be found out. So what do we know? We know that initial velocity was 25 meter per second. Final velocity is 0 meter per second because it comes to a stop. And we found out that the acceleration, which means the retardation, was minus 2.5 meter per second square. So we have U, V, A, and we have to find distance, which means S equal to question mark. Let us look at our formula. VUAS. Which formula do you see? This one. Okay, so let us write that formula. V square minus U square is equal to 2AS. What is our value of V? 0. So it will be 0 square. What is our value of U? So 25 square is equal to 2 into what is our value of A? Minus 2.5 multiplied by S, which we have to find. So 0 square is 0, 25 square is 625 is equal to minus 25 to 50. So 2.5 into 2 will be 5. Okay, so we have 5 multiplied by S. Make sure that your 5 does not look like S. Alright, so we will have minus 5S is equal to 625 with a minus sign here. So we will cancel the minus sign, and 5S is equal to 625. So S will be equal to 625 upon 5. 5 ones and 5 goes 125 times. So our S is 125 meter. This is the distance traveled after applying the brakes, and this is our answer 3. Okay, let us now come to question number 14. Let's read the question. A spacecraft flying in a straight course with a velocity of 75 kilometers per second fires its rocket motors for 6.0 seconds. At the end of this time, that means at the end of 6 seconds, the speed has become how much? Can you see this? It has become 120 kilometers per second in the same direction. Find number 1, the spacecraft's average acceleration while the motors were firing. The motors were firing for 6 seconds, correct? Number 2, the distance traveled by the spacecraft in the first 10 seconds after the rocket motors were started. Now this 10 seconds means the first 6 seconds, and after that there are 4 seconds. Alright, now we say that the motors having been in action for only 6 seconds. So the 4 seconds the motors were not in action. So let us look at the average acceleration. We are going to now look at the data. Let us write the data. Let us write the first part. We know that initial velocity of rocket was given as 75 kilometers per second. Now remember, we have to have our velocity not in kilometers, it should be in meters, which means 1 kilometer is 1000 meters. So 75 kilometers will be 75,000 meter per second. Okay, let us see what else we have to write. It is going to be fired up for 6 seconds, and at the end of it the speed becomes 120 kilometers per second. So we should write just that. We should say that the time here is, we'll call that as t1, that is 6 seconds, and then the final velocity of the rocket is 120 kilometers per second. Again, this is kilometers. 1 kilometer is 1000 meters, so it will be 120,000 meter per second. And they are asking us acceleration. Average acceleration is how much? Now, what do we know about acceleration? Your acceleration is the rate of change of velocity, which means it is v minus u upon t. Either use this formula or you can say v is equal to u plus at. Both of them are the same thing. So I'm going to use it like this. Acceleration is v minus u upon t. Our final velocity is 12, and these 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros, the 120,000 meter per second minus initial velocity is 75,000 meter per second, and that upon time I'm going to write here t1, which is going to be 6 seconds, and so we will have 45,000 meter per second upon 6 seconds. 6 ones and 6 sevens 42, remain 3, so 6 fives 30, and 2 more zeros. So that comes out to be 7500 meter per second. Per second means per second square. And this becomes our answer 1. Okay. Now let us come to the second part. The distance traveled by the spacecraft in first 10 seconds. Now in 6 seconds and then 4 seconds. So there are going to be 2 distances. Okay. And the rocket was fired up only for the first 6 seconds. That means 6 seconds there was acceleration. Let us look at the second part now. So we have to write distance traveled by the rocket in first 10 seconds after the motors were started will be the distance s1 for 6 seconds, the first 6 seconds, and the distance S2 for the remaining 4 seconds. So that is how we will have the distance in the 10 seconds. First 6 seconds and then the remaining 4 seconds. Okay, so we will consider the first part, that will be for distance S1. Now for distance S1, let us consider what we already know. Let me just change the color. We are going to have initial velocity is going to be 75 kilometers per second, and the final velocity is 120 kilometer per second. And during this, our time interval is 6 seconds, correct? And we have to find the distance S, how much. So we'll call this as T1 and we'll call this as S1. All right, which is the formula which will have V, U, T and S. Now remember that we have even acceleration. What is our acceleration? It is 7500 meter per second square. This is for our distance S1. We have V, we have U, we have S and we have A. Although we have T1 also, we can use the formula. Let us look at the formulas here. We'll have S is equal to UT plus half AT square, or you can use V square minus U square is equal to 2AS. Now I'm going to use this. We have V square minus U square equal to 2AS. This is the formula we are going to use. Now can you see our initial velocity is kilometer per second, final velocity also is kilometer per second. So this acceleration that is there, this acceleration we can also write it as not 7500 meter, but we can also write it as 7.5 kilometer per second square. It's going to be a little easier to substitute this value in kilometer per second when our initial velocity is kilometer per second and this also is kilometer per second. And this one is 7.5 kilometer per second square. So I'm going to substitute here. This V square is 120 square minus U square is 75 square, and that is equal to 2 into acceleration is 7.5 multiplied by S. Okay, so 12 square is 144 and these two zeros for the square. 75 square will be 5625. If you want to know how to find the square of a number ending in 5, I will put the link somewhere here on the right hand side here. I will put the link so you can look at that video also. And here it will be 7.5 into 2 is 15. So 15 into S. Now when we subtract this, we get 8775 equal to 15 into S. That gives us 8775 upon 15, and that is equal to S. Therefore, S is equal to 15 ones 15, 15 5 is 75, remain 12, so it will go 8 times, remain 7, so 585. So this will be 585 kilometers. So this is your S1. I'm writing here S1, 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 S1. So this is S1, that is in the first 6 seconds. Okay, so this is the first distance. Now let us look at the second part. So we'll come to B and we'll say for distance S2. And for S2, remember the motors are not started, the motors are not fired up there, and we are going to have T2 is going to be 4 seconds over there, and we are going to have the velocity is 120 kilometers per second. So since there is no retardation over here, it is going in straight course, we are going to have distance, that is S2, will be equal to velocity multiplied by time. So S2 is V multiplied by T2, and here we will write, since V is equal to your it's in a straight line, so this will be your displacement upon time. So your displacement is going to be V into T. So that's how we got this. Now velocity is 120 kilometers per second multiplied by T2 is 4 second. Second get cancelled, and you will have 480 kilometer. That will be in the remaining 4 seconds. Now we have to find the total distance in 10 seconds will be S1 plus S2. What is S1? In the first 6 seconds. What is S2? In the remaining 4 seconds. So S1 is 585 plus S2 is 480, and if we add them together, you have 1065, and we have got this distance in kilometers. And that is our answer 2. So I hope you have understood this entire method for this. It is a little confusing question, but you practice it 3 times, 4 times, 5 times. So if you practice this, you will find that it is much easier. So we have now completed question 13 and question 14. These were the doubts of some of my students, and I decided to make a video for that. Talking about the doubts of my students, I am also now nearly getting ready for my online course, and it is going to be in physics, chemistry and maths for class 9 and 10. Okay, and that is going to be for your ICSE. The link will be soon given to you. It will be in the description box. So keep looking out for that. In the meantime, thank you for watching.